All right, we've talked a little bit now about subatomic particles, the particles that make up an atom, and we talked about electrons. Remember, those are the negatively charged particles that go around the nucleus, and in the nucleus you have the protons and the neutrons. You're probably very familiar with a diagram like this. It's a very Jimmy Neutron type of diagram where you are shown electrons orbiting the nucleus in one dimension. What we know now is that this is not an accurate representation of an atom. An electron does not orbit a nucleus. What is actually happening, and we talked about this very briefly already, is that they are located in orbitals. So orbitals are these areas of probability where an electron may be found. So what you can see in this diagram is you have this initial layer, this small blue one on the inside where your first electrons might be. Once you go further out from the center, if you have that many electrons, if you go further out from the center, you have another round area like that. So again, electrons are likely to be in that area. As you add electrons, you're going to have additional different shaped orbitals. So what you see here are some different shaped orbitals, and these actually look like little dumbbells. And the idea behind these is the electrons are simply likely to be found in these areas. Okay, so this is a probability area, an area of where you are likely to find electrons, but not necessarily. And notice that this is a three-dimensional shape. They are not bound to circulate on a single orbit. They can move around, and they're very random in the way that they move. Now, there are several rules regarding how electrons fill orbitals. One of those rules is called Aufbau's principle. Now, Aufbau is the guy who essentially said that electrons are going to fill the lowest energy level orbitals first. And the lowest energy level orbitals are usually those that are closest to the nucleus, although not always, and we'll see some additional examples of that. But the first energy level that's going to be filled is this smallest energy level that is closest to the nucleus. Each orbital can only hold 2 electrons. That is part of Pauli's exclusion principle. Each orbital can only hold 2 electrons. So this blue one in the center is one orbital. This pinkish one that is one layer out from the center is another orbital. Once you get to these funky barbell-shaped ones or dumbbell-shaped ones, this single one here and this one down here, together, that is one orbital. So 2 electrons can fit into this one orbital, and they're just going to continue to move around, move past each other constantly all the time. Same goes for this plane right here. So you've got this barbell right here. And 2 electrons are going to move back and forth constantly throughout these two parts of this orbital. Same thing for here. Now, the interesting thing is that let's say you have a carbon atom. A neutral carbon atom has 6 electrons. So the first 2 electrons are going to be found in this blue, the smallest orbital. The next 2 electrons are going to be found in this pinkish orbital. Okay, so we have 2 electrons left. And what some people would first do, they would think actually, is that both of those electrons are going to enter into one of these orbitals. And then these other 2 orbitals are going to remain empty. In reality, that is not the case. What happens is each orbital is going to get 1 electron first. So all 3 of these orbitals are at the same energy level. And so if they are at the same energy level, what's going to happen is each orbital will get 1 electron before an orbital gets paired. So one of those electrons is going to go into this orbital, and then the other electron is going to go into this orbital. And that is how you would have the electrons for a carbon atom. Okay, so that initial layer, that first energy level, only has that one orbital. And then the second energy level has this circular orbital plus the three bell-shaped orbitals. Now, the orbitals can get to be very strangely shaped. And the thing that I want to mention first, before I show you a bunch of the overwhelmingly strange shaped orbitals, is that we're still looking at energy levels. So this is going back to Bohr's model. He said we have this positively charged nucleus and we have energy levels for the electrons. This is still true. And we're going to see that as you go out from the nucleus, the energy level increases. So here are some of these very strangely shaped orbitals. And I don't think you can see it very well here, but this is the first orbital. It can only hold 2 electrons, and it's just this one circular, kind of spherical orbital. The second orbital, the second one that electrons would fill, is another sphere, but now it's going around the first one. So think of this first one now kind of being inserted in here. It's this next layer. Kind of like an onion, you're going out from the center, you're adding layers. Okay. At the same energy level are these 3 orbitals. Now, these are those dumbbell-shaped ones where it looks like 2 pieces, but it's really just one orbital. So here's one orbital, here's another, and here's another. So at this first energy level, where you only have this one spherical orbital, it can only hold 2 electrons. The second energy level, however, can hold 2 in this orbital and then 2 in each of these. So the second energy level can hold 2, 4, 6, 8 electrons. Okay. Once you get to the third energy level, you can still hold 2 electrons in this orbital and then 2 in each of these. So 2, 4, 6, and then 2 here, that's 8. So again, there's 8. As you go down, you are going to increase the number of electrons that can be held in each energy level, which intuitively makes sense because as you go out from the center of the atom, you have more and more space for those electrons to kind of spread out. Remember, they are negatively charged. They don't really want to be near each other. Okay. So right now, I just want you to kind of get an idea of these orbitals, these interestingly shaped orbitals, these areas, these 3-dimensional areas of probability where electrons are likely to be found. Eventually, you get to these very, very strange shaped ones, and the way I want you to think about them is they're filling in all of the spaces. Okay, so if we go back to the picture that we were looking at a minute ago, you see this one, there's a bunch of space that is left open here. Ultimately, electrons, this is going to be the lower energy level, so they're going to fill this area first. But as you add more and more electrons, they're going to backfill this space. So these little areas over here are lower energy than areas out here. And that really has to do with the attraction between the electrons, those negatively charged particles, and the positively charged protons in the nucleus. It's going to require less energy for them to go ahead and just be in here in this little area versus further away from that charged particle. So that's all for the orbitals. We are going to look at how to determine which orbital gets filled first based on Aufbau's principle.